Okay, electron configuration. What you got to remember is this first circle here. This is the nucleus, all right? We're going to act like it's the nucleus. On the top, we're going to do the proton count, and on the bottom, we're going to do the neutron count, all right? We find the number of neutrons by rounding the decimal number on the periodic table. We round it if it's 0.5 or higher. If it's not 0.5 or higher, we leave it the same. For example, germanium. Germanium says it's 72.6, so we round it to 73. All right, that's the first step. We find that average atomic mass, the number with the decimal, and then we round it. Then we subtract the number above it from it. So carbon's mass is 12.01. So we round that to 12. And then the atomic number of carbon is 6. Well, 12 minus 6 is 6. All right? So carbon has 6 neutrons. What's its proton count? Well, carbon's atomic number is 6. The atomic number is the number of protons. The number of protons doesn't always match the number of neutrons. So don't fall into that trap. Always do the math. Average the number of the mass, subtract the atomic number from it to check to make certain that you have the right neutrons. But we're here to do electron configuration. The number of protons always equals the number of electrons. So we've got 6 protons, which means we're going to be working with 6 electrons. We're going to be placing 6 electrons, right? This is the first orbital. This is the second orbital. And some atoms have a third orbital or more. All right? All right? Just don't confuse that first circle and say that's an orbital. That's the nucleus. All right? Let's clean this up. This first orbital here can have a maximum of 2. I'm just going to put a 2 here to remind us. Second orbital here near my little cursor can have a maximum of 8, and the same with this outer orbital, have a maximum of 8. All right? How many electrons are we dealing with again? Oh yeah, 6, right? Because this says 6. The number of protons has to equal the number of electrons. So we're going to start from the inside, we're going to go to the out. And I like to go clockwise, okay? I like to go like this, all right? We start by placing them singly, and then we can pair up. And this is what I like to do. We have 6 total, count out loud, okay? Here's the first, all right? And then I have the second. They have to be as spaced out as they possibly can be, right? First and second. Well, we've hit the maximum. That first energy level, that first shell, can only hold 2. That's it for that first one. But we have 4 more to go, right? Because we have 6. So we've done the first, we've done the second. Now watch this. Here's the third. We want to equally space these out as far as possible from each other. So watch the pattern. Here's the third, the fourth, the fifth, and the sixth. It's kind of like north, south, east, west. All right? We want to keep them spaced out as much as they can. Let's say you do carbon. Let's do something a little bit more tricky, okay? Let's do magnesium. This takes practice. It's simple, but it takes practice, right? Nucleus. Clear it out. Let's do magnesium. It's Mg on your periodic table. Mg. Now, magnesium, find its average atomic weight. It's the number that has the decimal. and mine shows 24.3. That's the mass, 24.3. Well, 24, we just round it to 24, and then we subtract the atomic number from it. We subtract 12 from it. How do you know it's 12? Periodic table. You find mg, you find the number with the decimal, you round that up or down, and then you subtract the number without the decimal from it. 24 minus 12 is 12. Proton count is 12. Neutron count. Remember how we do this? Right? The proton count is 12 because the atomic number was 12. We found the neutrons by the 24 minus the 12. It just so happens that it equals the 12. Okay? It's not always though, but always do the math. Let's place these. Remember, this first energy level has 2 max. The next one, it's 8 max. The next one, it's 8 max. Okay? This one's going to get a little bit tricky. All right? So we have 12 we're dealing with. Let's count them out. Here's the first, the second. I'm done with that circle. I'm at maximum. Here's the third, the fourth, the fifth, sixth. Now we don't jump to the next level. We start to pair. You start to pair them up. So that was the sixth. Here's the seventh, the eighth, the ninth, the 10th. Well, I've filled out, I'm at 8. See, I'm at 8 at this circle. So I'm maxed. I'm maxed there, so I've got to go to the next circle. Right? How many are we at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? I got 2 more to do. So watch what we do. Okay? 11th. And do I put 12th here? No. You put them at maximum distance from each other when they're not paired up. So it's similar to this first orbital. We put the final electron, the 12th one, down here. We want to space them out away from each other. Here, let's get that out of the way, if I can. We put it all the way down here, okay, in the bottom orbital, okay? For practice, we want to go clockwise, first putting as singles, and next pairing up, if the orbitals allow it, all right? It takes practice.